Let's solve the remaining hard problem of the HEAP problem. First, the design the Twitter. That's what the problem is that design a simplified version of Twitter where the user can post tweets, okay, follow, unfollow another users, and is able to design see, okay, to able to see 10 most recent, okay, Twitter uh, tweets in the user's news feed. Okay, so Twitter in a slide. First, you have to implement a class like Twitter. Initialize your Twitter Twitter object, Twitter post user ID and tweet ID. Okay, so it's a tweet ID, tweet ID or Twitter is concept called who might be unique Twitter ID. Okay, okay, and get new. Retrieve 10 most recent ID in their user feed. This item and news feed must be the posted by user who the user followed or by the user themselves tweets must be in order from the most recent to least recent. Okay, पहले आने वाला बाद में आने वाला follower ID and user started with the follower ID and followees ID. Okay, unfollow, so unfollow. But we have studied like more study one. Now again get new. So if get new is vector. Let's get new. So Twitter dot get only first user one. It should be list with one. It's like a Twitter ID, right? Tweet ID. So it's fine. Okay. Now let's move. Follow. Up to just 1 and 5. Now just what's the recent like how can we decide like the most recent? You can use the queue. Yeah, you can use the queue. Okay, fine. Let's suppose we use the DQ for the most recent to least recent. Now again what? Now again what we have to do? Let's suppose the Twitter ID we can get. So we provide the Twitter ID, right? Get news user ID. Okay. We provide the Twitter ID. So you have to just take the user ID and the ID, no, DQ. Front stack. Yeah, you can use the stack. Now let's move to follower ID. So follow the user. Okay, the user follows. You can take the follow and follow. So let's suppose we have one follow. So it's like a follower ID and followee ID. The user with ID started following user ID with followee ID. Okay. So so user with the ID follower started following one. I started following the two. Right. Okay. Non-follow. User with follower ID started unfollowing. Let's remove this. Now let's move the next question. First we have to one. We put 5. Now we can get 1. So it returns 1. Now again it's the following. So we put 1 into 2. Now again the post ID. So again we have 1526. Now again, now again, get tweet ID. So it's again returning the 5. I think it's a returning 5. Why we are getting 2? Uh, just start to follow you. User post a new post IDT. So user will return at least 2. After the ID 6. I know, but why? Like the one or two connected, it's become connected. So it's that's a good question, right? How can we connect all these dots? The question arises like right, right. So how can we connect all these dots? So we have to think like a post RD, post tweet RD, compose new tweet RD. If we take like if we take like we can take like one. We take the user ID, user ID, take a tweet ID, five, nine, six. So it's like a recent, and recent ID should be user feed, user news, open user news, and the feed is posted by the user feed, and each element in the news must be posted by the user who followed, or the user him themselves. It must be ordered from. Okay, so it's following. We have to check like one follows. We have one. Now one follows two. If one follows two, then what we have to do? We have to do like one follows two. So two is six, right? And the two's follower, all two's follower, one follows two. If two is posted, you have to add here six, right? So what you have to do? Which data structure can I use here? Like if you use in map, we use the post ID, and for if it is connected, we can use how much? It's like with ID 100,000. So we can use it like right. So how many follow ID? Yeah, you can proceed now and square. How? Let's suppose, yeah, let's suppose we have one or five. So one and half, five. Now we get six. Now we have follower. We are following two. Okay. Now we can get two six. Okay. Now we have to one. Is there relation between any if the if, if it follows anyone? Yes, I follows one. So I can go and push front into it, right? So we can use the map in and the vector, sorry, dq, sure, dq. I think yes, we can use the dq. Most recent way, so we can use all the connection. And if it is unfollowed them, so we remove this and we remove this also, right? We remove this and we remove this. We have to what to do? Just take a map. Let me first verify all this with a dry run. Right. Like, what can I do here? Like we have take a map and of int and dq. Right. So 1, 5. We get a 1, 1. So we return the 5. Now the follows 1, 2 and 2, 2. That means it is a follows and it is a follower. Okay. Now we have to just move to 2 or 6. Right. So we put 2, 6. Now the question arises, is that 2 have any follower? Yes, 2 has followers. Which is the follower? 1. So let's go and put 6, 1 there. Right? Okay. Okay. Now we have just just 1. So we remove. Now we get 6 and 5. Okay. Now again we have to unfollow, right? 1 and 2. If we want to unfollow it, first get unfollow. So if the 2 has an follower, yes. So you have to remove the all the from the 2, right? Which is present in 6. It's not like a distinct element. What we are doing here, tweet ID. Yeah, it's distinct. It's a distinct. Okay. So just remove the tweet ID. I think you have to just remove the tweet ID. Just remove the tweet ID from which is present here. Just remove. We are remove all the tweet ID which is present here, right? Now, and we remove this. Now we remove this. Now we have to return 1, then we return a 5. So what we have to do here, like what I am trying to do, just take a unordered map of int and pq. Sorry, spelling is right. Dq in what post, right? Now what we have to do, just take a unordered map in it's a following following and the follower, right? So now what we have to do, just mp, sorry, post id dot user id dot push front tweet id tweet 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 id, right? Just you have to do this and you have to return. Now in this era, what we have to do, just take a vector. Okay, sorry, answer, travel all the way, what, post user id and answer dot push back x, right? And return the answer. Now what we have to do here, in the follower id, Okay, I think here we have to push here something like after pushing this, we have to check what that how many followers photo x followers followers right followers of that user ID. Let's suppose we have follower of one. Let's suppose we can get one. Now we have to push also and it's we have to post and the user ID user ID user ID post to user ID and we have to post dot x dot push front what x, this is x, right? Okay, so x, yeah, this this much, this is good. Now in the following list what we have to do, just nothing to do, just do following what we have to do, whose I have followed, I am the follower ID and I am following the this ID, right? And the follower I am the I am also the follower and the follower, not a followee ID and the follower ID, right? This much good. Now we have to see the unfollow. So this is the one like how to approach this. So unfollows. So just what you have to do, just find for auto x. mm, what we have to do here, follower ID if we are following someone. Like the follower, all my follower. Yeah, all my follower of my follower of following ID. So, following ID, all my follower of following ID. So follower of following ID, just take the photo of x into following ID. It's a following ID that is two, and all the two remove from the followers follower ID. Just remove from the follower ID, right? All this, all there is just remove from the follower ID. Like take a DQ in Q or if x is equal to 4 photo x what post of follower ID if x equal to x, continue, else else q dot push front push backward xx. Now after removing from this, just remove the following dot follower. So it's like a more follower now. Why are you entering like a vector? So it's like a vector, right? Push back. So just take a set. What? Just take a set. So we can erase easily. Insert following ID, and same goes for this dot insert follower ID, right? Now we have erased from this, so we just follower ID dot erase the followees ID, and the follower dot followee ID dot erase the follower ID, right? Now what we have to do? Just post is equal to follower follower ID is equal to q, right? Let's see this passes of the test cases or not. Q dot what is q? It's q push back. I think this is right. What? Push back at q. Okay, not a q, dq. 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 Wrong answer. Why? It's removing. It's not removing, right? Why? Why it's not removing? Like the follower ID. To have okay, 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 sorry. Not this now. Not this much now. Follower ID. What we have to do? Like, uh, like for two, for two, all the post of two, all the post of two is removed from the. Let's suppose the follower ID. So two have follower one. So one follower X follower one have follower X has follower one. So all the post from the two removed from the X. So it's like a photo X post of following ID, right? So photo of YY is equal to what? Post of what? X. If X equal to y y. Then continue. Else you dot push back what y y. Let's try to. I think this gives the wrong answer. Yeah, this gives the wrong answer. Why? Let's see the test cases. Like so, post ID one. We have put one. Now get feed. So two. So it's remove two. So it's null now. Why returning one? Now let's follow up. Let's follow up. One. So I. What we have to do here? Just what we have to do. Are you teaching? So what we have to do here? Like post ID follower. Now what we have to do? So what we have to do here? Like we create the object. That's right. Now we have to put it out like this. Now we have to put this back right. What we have to just like post ID one is to one. Now what? So it's let's suppose we can get news feed. So it's return one. Okay, ID return one. Yeah, return one. Got it. Now the follow up. Now two follow one and one has follower two. One has follower. So two started to following one and what gain one follower. The user ID one get one follower. Now the news thread two. So if this came, then this return a null. Now the unfollow button too, it will do a null. Okay, so it's like a null. So it's like a null. Now get the user info one. Now follow button, get a null. Okay. Now user one. Okay. So what we have to do here, like we are trying to post ID. Okay. So follow user ID to post ID to if you follow if if two following one following, then we have to put here also what what also follower, right? Two follow one. All the all the post of one get into two now. Right. Right. All the post, right? All the post, four, four, auto, all the post from the one, from the following ID, right? From the following ID, all the post from the following ID should be inserted, right? Should be get by one. Now how? Is it recent, most recent? Or if we take like the following ID, if you and try to post, try to put, but the question is right that how can we put it like the it asks for the most recent one, like so which one is most recent, like four. So if a post dot follow our id dot post front post front x, if we post back front or if it passes all the test cases, if it pass, let's try to submit this code. It is, yeah, no. So 1 and 4, post ID 1 and 4, 2 and 5, again 1 and 2, 1, 2 are connected. So 1 have 4 and 5, 4 and 5, 1 have 4 and 5. Now unfollow, sorry, they are not following, yeah. Why are unfollow? They are not following. Unfollow. In the unfollow, what we are trying to do. Okay. So if it is for them now, if it is for them, if it is follower, if it is follower, then we have to. Yes, no. They are not following each other. Like 1 and 4, 2 and 4, completely two different. They are two completely different. So why we have to follow, right? So what we can do here? Uh, if the follower, sorry, follower, follower dot count or follower, follower ID, not count, just return, right? Just return. If the follower point ID is not following, so we have to just return. Again, this is not much what, and the same goes for following dot count is not follower dot ID. If they both not are, if anybody is not, so we have to just return the value. Pass compiling wrong answer. I think this much. Why this? Aren't we use the set multi-set? Multi-set. Duplicate values. Single values. Duplicate values. If you use the vector, don't think so. This can solve. So what we have to do now, we drive all the data structure like map, queue, follower, multi-set, nothing much. But what we have, let's think differently. Like how? if we take the DQ, right? The DQ is right. If we take like a data structure of, if we take the data structure, right? Like what data structure? They that means they asked for the timer. If we take like a data structure like a priority queue, like okay, let's start with the priority queue, right? If we are able to solve using priority queue and map, what the map should be like we have one, so we can use the quick like a timer, a quick ID, right? So like the 1 and 5 we get. Now we use the 0 and minus k and n minus 1. 30 is the 4 Now what we have to do here, if we take like what take the unordered unordered map of int and unordered unordered set, right? If we take this much what following, right? And same the we take map of int and vector of int of weights, right? Or let's take a what? Let's take a rank. Rank is equal to g. Sorry. Let's take rank and initialize a rank is equal to 0. It's tell about that how much rank. So tweets, so just tweets, tweets what? User ID, user ID dot push back what? What we have to do? We can take here the pairwise rank plus plus and the tweet ID, right? Now from the following ID, what we have to do? You have to just take a following ID, following dot following dot follower follower ID dot insert the following ID, right? I am following you, this indicate, and I am going to unfollow you. I am going to unfollow you. So let's erase the following ID. Now the question arises here. How can we do it this like? First of all, no. The question not it's like here we have to just put it like what what we have to do here, we have to just use the k int k is equal to 10, right? 10 10. So now let's Let's see what is the size size of the size of the tweet tweets dot user ID. This is the size of the tweet user ID. Now we have to just what what we have to do, like push back, so it's frequent, so it's take and I is equal to from the last, because most recent is the pushback, we are pushing from the back, and should be greater than maximum of 0 or and size minus k, right, and k minus minus. Now we have to just push what, just take a here, take a one data structure like priority queue, what priority queue, what to priority queue. So you can take priority queue of, I think we can take a minimum priority queue, right, because we want the maximum, that is most recent, that means that rank should be greater, so we take that much, sorry, here in 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 and the greater pair in in pq, right, just pq dot push, what what we have to do, push like tweets and I dot second, right, second. Now just push the second, are you sure? Yeah, just push tweet I, no, not like this, user id, user id, right, push I, because we are taking the priority queue, right, and if the pq dot size increase the k, so pq dot pop back. So now again we have to just take what, like we are taking like two, so we have to take like all the follower of the user id, like all the following, we have to push into all the following, right, so it's a follower, sorry, following following of user id, give me all the follower that user id, right, and just do same process of this, like size as j, sorry, as j is equal to tweets dot following and just push as j minus, as j minus 1, as j I is equal to maximum of 0 and the as j minus k and s minus minus. Now we have to just move, we have to just push pq dot push what, just tweets tweets following dot I, and if the pq dot size greater than k, just pop back. Now right, this is all. Now in the last answer, just travel all the pq dot size, pq dot size, right, pq, no, sorry, pq dot empty, answer dot push back what, pq dot top, dot second, and pq dot pop, right, and what we have to do, just return the answer. Let's see this passes all the test cases or not. What? So this like unordered set or unordered set. Oh, spelling mistake. Unordered. Un like unordered. All good now? Unordered set intent following. Unordered vector. Vector following. Okay. Un. Okay. 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 Sorry. 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 R. Order. Order. Unordered. Right. Now good. But all good. I think. How about this? This much for this. Oh, yeah, one bit extra, right? This even this one this. For this three. User ID, user ID. Priority queue, pair, greater wide and size. Tweets, not tweets. The tweets from map type and size. Okay, 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 okay. We are not making the size. No, how good. What the fuck? And the big codes give the why? Yeah. Pq.push.I. Did you mean tweets? Yes, I mean tweets. Where user ID, user ID, any other? No. Now we have to run. अब चल जाना भाई बीमार follow ये ID. Hmm. Oh, okay, okay. So what? We are not reversing. We have to reverse now. Answer dot begin because we are storing from the back side. So we have to reverse. Now we now I can see that this might be provide right answer. Yes. Now let's try to yeah, this passes all the test cases. Yes. Using the priority queue, we can get main is the rank. We have to initialize the rank for the knowing the most recent and least recent, right? The next question should be minimum cost of connect sticks. So this one is my solution. Follower ID. जितना भी फॉलोवर है मेरा फॉलोइंग आईडी को जितना भी फॉलोवर है मेरा all the followers of mine I can provide you one follows two. uh, this is premier site. So let's see what I am trying to do to this much good. Now next question. Let's move the next question. What this question said that given the array of the length, okay, AR is the rope of length, connect all the rope into single, the minimum cost, the cost to connect all the is the sum of their length. Okay, 4 to 7. 7 to 19. What we have to do here? How can we approach this? So like connect all the rope into single row one with the minimum cost. So and the rope. Okay. So first of all, we take what is the cost? How can we cost? The cost to connect to the sum of their length. Okay. 4, 3, 2, 6. Now if we take this, so it's 7. 7 to 6. Now it's 9. So 9, 6. So it's take like this much. How to connect? So it's 9 and 15. So what we have to do? Just like 7, 9 plus 15 or 15, like a 16 plus 15. It's more like an order. So first try to connect. First we have to take all the element in a minimum priority queue, right? Because we can use the sorting, but I am solving that heap problem. That's why we are mostly use the minimum heap. What minimum heap can do? Like 4, 3, 2, 3, 4, 6. Not it's sort like 2, 3, 4, 6. Now 2 and 3 become 5. Now 5 and so the cost is 5. Again the 5 plus 4, the cost is 9. And 9 plus 6, the cost is 15. So it's 29. So let's do using the priority queue. You can use the sorting algorithm. That means you can use the sort, but I'm using here the priority queue. Priority queue, right? In vector, int greater, int pq. Uh, let's put it all. Not x array dot push. Sorry, pq dot push I. Now let's take the post is equal to 0, post is equal to 0. Now while pq dot empty, what we have to do? not empty, but the size should be greater than equal to 1. Size, size. Now let's take what in first one, pp dot top. Now in second one, first, second, pp dot top. You have to just copy it, pop, pp dot pop, and the pp dot pop. Now new length should be length, new length. I think the spelling is right. So first one plus second one. Second one, this one is new length, and the post is plus one new length. The post is, sorry, the length. Hmm, length. And pp dot post what? New length g. Now just return the post. Yeah, this passes all the test all the not. Yes, this passes all the test cases. So this is bit a easy question, right? It's not a hard question. Now let's move the next question. This is your question, I think. It's a easy question. So what the kth largest element in the in a stream? Okay. So what in a stream like the kth largest element? Okay. So you can use the priority queue, right? So first of all, or you have to given the kth largest element. So 4, 5, 8. This is the kth largest element is 4. Now it's again come 2. So it's remove right. Yeah, we have to do what we have to do. What we can do here. Now, first of all, the kth largest element, if you ask the kth largest element this add, so you have to add that much in priority queue, not return the present. Okay, so you can use the priority queue like here, right? Like let me first try run it up. If I am right or wrong. So it's like a 3. So 4, 3, 6. This is good. A is 4. So return the A4. A4. A slide with a stream of text int variable. Add the value stream. Return the clear clarification the score so far. So it's 3. So it's more like a 3. So it's removed. Now it's 5. So 5, 5, 8. So it's remove 5. Okay. Now we have to do what? Just take a priority queue. Priority queue and take a minimum priority queue, right? Take a queue, right? And just push just auto x none pq dot push x, and if the pq dot size is greater than k, just pq dot remove pop back. Right now pq dot push value, and if the pq dot size is increased by k, increase into k. Okay, so we have to just k is equal to 0. K is this, and just take k is equal to this, and just take this big one, and pq dot pop back, and just return the pq dot top. Right. Let's see this passes all the test cases or not. Not. Y pushback size Y inside 3 dot dot Y is this you mean yeah this process of the test cases. Yeah, this process of the test cases. This is the TG side of question. Now let's move the next question. Maximum sum combination problem. Like what is this question said? That you are given the integer of a and b of equal size. Okay, a and b. The sum of combination formed by the adding one element from a and one element from b. Okay, and using each index pair I and j at most once, return the k minimum, k top. Okay, top maximum sum combination. Okay, so if we want to take the maximum sum combination, we have to use like a 3 and 1/4. So it's like a this much solution, like a 7 or the 3 or 6 now. Why? The combination is like at most once. Okay, so using each pair at most once, you can use that most pair once. You have to just use pair at once. So what we can do here? It's 1 hour, 1 hour 2 minutes. So you are given two integers, nums equal to size. Now if we take the priority queue, like you have to return the just sort it out. If you sort it out like 2, 3, 1, 4, this becomes the 7. Now it's become 7. Now it is become this 6. This one is combinational. Huh? So now let's see. Let's see. 1, 1, 2, 3, 4, and 1, 2, 5, 6. This and this. Okay. And this, let's suppose this one and this one is 9. And this one and this one is 9. So they move it out. They move it like out from this to 9. Now see this and this 9. So this 9. How can we solve this using priority queue? Priority queue. Okay. Let's see priority queue 1, 3, 4, 9, and 1, 5, 6. Okay. So if we use the priority queue, of maximum priority queue, let's see maximum priority queue of 5, 4, 2, 1, 4, 3, 2, 1. Take the 4, 4 and 4, 3. Okay. So it in the 1 8 condition like 6 and 4. We take 6 and 4, 10, it's 10. We have both. We have 5 and 3. So let's make a combination of this and this. So the maximum we get 9. So we have 9. Uh, we get the maximum 9. So just remove it from the 9. You can't get this one. Okay, this one. Now it becomes like this one is good. Now we have to just use the this one and you can't this one. Use this one. Use this one. So again 9. Again 9. Not like a box. Okay. This maximum and this maximum can use the pair way, right? But if we go there might be a greater movement, right? We can't do it. So it's like more like a structural. How can we approach this? The question arises this. So what we have to do here, just if we spot the element 1, 2, 3, 4, and and what? And the 1, 2, 5, 6. Now let's see. 10, 9, and this. Okay. What you have to do? What you have to do, right? What? 1, 2, 3, 4, 4, 4, 4. 1, 2, 3, 4. So you have to do just nothing to do. Like 6, 10, 9, 8, 7. Right? Now from this you have to 9, 7. This needs this can do. This can I think this can solve the problem. Let's let's see. Let's suppose we have 1, 4, 7, 8, 4, and 4, 3, 2, 1. Now we have 1, okay, 2, 2, 4, 4. Now 1, 5, and 3. So 1, 1, 2, 3, 4, 4, and the 1, 2, 3, 4, 5. Now we have 1, 9, 9, 8, 7, 7. And again we can use here from here 8. So it's like a 7, 8, 9, 9. Removing 7, 8, 8, and 9, 9. It's a 4. It's a 4, and the 7. It's a 6. Now it's 8. So it's removing 8. Putting here. Again it's 7. So it's removing 7. Okay. So we have to just take a PT, right? Or you can use the here 4. You can use here 4. This is the principle now. Right. Each pair you can traverse, take the window size. Like from here, you can use here. And from here, you can here, and this total size. It's more like a how can we prove the brute force without using the brute force approach? Like me here, here, here. I am traveling to n square and I am traveling for n square. I am n square. So it's like n square now. Traveling. We have to just take this one. 1, 2, 4, 4. 1, 2, 3, 3, 4, 5. This one good, this one good, this one good. Just take all the friends. You have to take all the problem, right? You have to take all the problems. You have to take on all the problems, like all the sum, not a two third, but all the sum, like a 3, 4, 4, 7, 5 priority queue. You use the priority queue, like maximum priority queue if you use. So 4, 4, 3, 2, 1, 5, 4, 3, 2, 1. This 4 and 5. Yes, I got 9. So it's a 9. Now 4 goes this, and 4 goes 5 goes this, and again both are goes this. So it's like 8, 9, and 8. So it's like maximum 9. Now just we have to remove this much solutions, which is greater. This is greater now. Great. Just take a 4 now. Just take this much. What we have to do here? What we have to do here? Like, if we use the priority queue, if we use the priority queue here, wait. Like, if we use the priority queue, like priority queue, what? If we use the priority queue, what we have to do? So if we take n and n, we have to just what? Take the first one and the second one. We have to just put it at like right. We have to just sort sort a dot 3 begin. A dot 3 begin, right? A dot 3 begin and a dot 3 end, and same for the a dot, not a re begin but a begin. Same goes for begin and a dot and b dot end. Just take the and a dot size. What we have to do? Like we take this one. Okay, okay, okay. That's it. Take a priority queue. Priority, priority queue, queue, queue. What? Priority queue pairwise. You can take a vector, right? Just take a vector. So now push the priority queue A and minus 1 plus B and minus 1. This one is first one. Now second we have n minus 1 and third minus 1. Now while the picky dot not empty, just take the last index I1, which is p q pq dot top is 1, idx2 pq dot top idx2, right? Now pq dot pop. Now just tell me. Now just tell me how can we approach this? Just take answer dot push back. Push back what? Sum. Take a sum, right? What is sum? Sum is equal to pq dot drop 0. Yeah. Now k is not 0. Pq not equity. Take a k, right? K should be greater than 0. What is k? K is like a k is like a n. K is like a n, right? Now what we have to do here? You have to just take. Yes, sorry for the trouble. So, what? Just take a set visited. If I given one greater than zero and visited dot count. If it is not visited dot count, visited dot count, we have not found that one minus one and two, ID two. If it is not found, then just visited dot insert what n minus one and n minus one. If it is not found, then pt dot push what we have to push. Mm, just push the a I d minus one plus b I d two and the ID one minus one and ID two and the visited dot insert what ID one minus one and ID two. So let's again put it like ID two minus one greater than zero and is visited dot count not ID one and ID two minus one. Then we have to just push what ID one plus b ID two minus one and the ID one and ID two minus one and just push into insert into insert into what? Mm, like ID one and ID two minus one, right? This one is good. Now sort, we have to sort the answer dot begin and answer dot end and return the answer, right? What we have to, what is k? They ask for what is k. So if k is given, then what? Answer dot push. Oh, okay. Answer was not declared, right? So we have to just declare answer. Okay, 5, 6 sort. Okay. This sort into begin and end. Yes. Let's see this passes all the test cases or not. Yes, this pass all the test cases. So now let's see. I solved the problem previously. So I solved using, yeah, I solved this first. So this is good. Now let's move the next question. Like find the medium from the data stream, right? What? You should solve the tough problem. Oh, you should solve the tough problem. Okay. Hello. Yeah. Tell me. And next question with the first solve by this question, then go to this. Okay. So first the top k most frequent element. Given the given an integer nums and integer k, return the most frequent element. You may return the answer in negative order. Okay. Most frequent. So it's like a 3 to 1. What we have to do? Take a map. Okay. Take a map like first take a nums dot size, although it is not જરૂરી, and take a map and frequency for the frequency, right? Now store all the elements frequency, right? All the element frequency. Now take a priority queue. What? They say that most frequent. So take a priority queue of minimum. That means the pair wise minimum priority queue, right? Pair wise minimum priority queue. PQ. Now what we have to do here? What we have to do? Mm, let's see. For auto x frequency PQ dot push, right? Push what? Push frequency dot, sorry, x dot second and x dot first, right? So it's a smaller than, if the PQ dot size is greater than k, just PQ dot pop. Now what we have to do here? We have to take an answer and travel all the PQ dot empty and the answer dot push back PQ dot top dot second and PQ dot pop, and just return the answer. Or it's a compiler while giving this. So this much. You can use the different approach, right? Like a comparator function, right? I think I solved this using the comparator function. Let's see. Yeah, I no, I solved same as practical. You can use the practical. Now let's move the next question. Like this one is a good question, right? So find the medium from the data stream. The medium is the minimum value in the ordered integer list. If the list of the list, if the size of the list is even, there is no medium value, and the medium is the mean of two. medium value. Okay. So size, for example, the size is 2, 3, the medium is 3. For example, 2, 3 is 2.3. Implement find the median. So it's more like approach at the medium and return find the medium. Oh, so this much is not that much good. You can use the vector, I think, vector. Okay. Take the minimum map, take frequency return. Yeah, you can do that. JS. Oh, that's good. JavaScript. Okay. So what we have to do here? Let's try to find this using the vector, right? Let's take a vector, temp, right, and adding temp dot post back. No, no, not a vector, not a vector, not a vector. You have to sort like just take take set, not a set, but a multi-set. Multi-set. Might be possible that it contains the duplicate value, right? Now multi-set, multi, multi-set, sorry, this empty. Now empty dot insert, insert, insert nums. Okay, num. So this become the, now we have to size empty dot size. This become the good question here. Here the question become good. There is one instance like if the size is odd, we have to find the median, like a mid one, each size divided by 2 and mid 2, like 1, 2, 3, 1, 2, 3. Uh, so I don't think we can use the medium here because it gives the TLE, right? So we have to use some other data structure. Let's try to use like let's if we try to use the priority queue here, like 1, 2, 1, 2, and 3. It's come like not. Take a take a bow. Mm, I think in the CSCS problem I solved the same question, right? Let me CSCS problem set. I solved one of these questions, same problem. Let me first log in it out. Yeah, I solved the problem. I think I solved this problem using the two set data structure, right? Mm, I think maximum, minimum, extent, traffic, sum of next nearest, greatest divisor. No, 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 no. Next check, valid, coin, subarray. Where I solved this problem with Rome, number beauty, no, not in the dynamic programming, not in JS, change theory, not. I think I used, yeah, here. Find the minimum, find the minimum, yeah, this question. This question I solved, in this question I solved using the like two set problem, like multi set of two, min half and max half. We can use this problem, this same concept here, right? So let's see. You can solve this problem. Now let's see. What we can do here, like we use the priority queue, right? So one priority queue, one, two, priority queue. Just increase the size. If we're taking the priority queue here, it's coming like 2, 4, 5, 1, 3. Finding 2, 4, 5. So it's like what? Just remove here, here, here. Here. Okay, the size is not. In future, it becomes size is not. So we have to remove now. Hmm. Max, max half and min half. So one. Now it's again come to. So it's come to. Now it's two. You ask two. Return the answer. No, it's two. Four and two. Min half. Max half. So it's like two. Come to me. Now it's become four and two. Next four. Four and two. Four and two. Now if they ask from the they if they ask you the if they ask, so you have to return five, four. Now what we have to do here, like mm, we have to use what five. Mm, First to introduce. Now it's become again four. So it's four two. Now it's uneasy. So it's become two. Now it's equal. Now we have to just take like this. Adding, removing. What are you doing? Adding to find the minimum we begin. The medium in the adding solution. Hmm. First, I have to understand like to insert it, mean half, to insert it, then nothing, nothing. All things are zero. So we insert mean to each medium. Value come four. Value is greater. Max sum insert four. If the size is greater than a plus two, What is K? K changes. Yeah. This is particularly good. Now we have to move size is to not some. This is good. Now we have to click. Now else again we have to 153. Now again four come. Now again two check. Yeah, five come. Then we have to insert four and five. Now it's three, one. If the maximum half is greater, then we have to insert min half insert dot max dot begin. It's like 2 4 4 2 and just remove from there max begin 5. Okay. Okay. Now again one come. If they ask no one ask for the this they ask for this now. Okay. Now one come. Now one comes, then one comes like this not so one comes inserting in here, inserting here like 1 2 4 and the 5. So it's re begin. It's re begin go to here. So it's like 4 and 5, 5 and 4 and 1 and 2. 1 and 2. Now it's asking from the length. If the length is so can can I use here same approach? Multi-set, multi-set, multi-set in max half and mean half, right? Max half and mean half. Uh, from adding like like int medium, like int median is equal to if st dot it if if the mean half mean half mean half is empty, then just add minus 1e9, else add the mean half 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 re begin and let's see if the median is nums nums, so we have to just insert into the max half dot insert the nums and size would be what size would be mean half size plus max half size, right? If the max half size is greater than sj divided by 2, what we have to do? We have to do mean half dot insert what we have to do? Max half insert max half dot begin and the max half remove erase erase max half find max half half dot begin. Right. This one is right. Else what? Same approach I do here. Same approach I use here. Right. Just copy from here and paste it out. So we have to use like nums and just copy from here, copy and just paste here, right? And sj plus 1 plus 2 plus 2. Yes. Mm, we are adding. This is good, right? Now find the median. So int sj is equal to mean half, mean half half dot size and plus max half dot size, right? If sj is odd, just return the mean half dot, just return the double. Yeah, double mean half dot re begin. Else double m1 is equal to max half begin and double m2 is equal to mean half re re begin. And the answer should collect the m1 m2 0 0 m1 plus m2 divide by 1 2.0 and return the answer. This should be passed out test, I think. This is wrong. Why? Let's just ask from the chat GPT. Why this? Your approach is firm, but fundamental. You are meaning to multiple normally half service instruction. So median. So correct handly after incident balance the actual size. Okay. So this one is right. Okay. Actual size. What I am trying to do. This is not a good instruction. Okay. Let's try to do. Not right. Not not this. Not this is not the right. This is not. The right. Right. how can we insert if the mean half is empty, just half mean half dot insert num, right, and return it from here, return returns from here. This is good. Now next, find the median. What is median? Median is mean half dot begin begin re begin. Now if the median is greater than the nums, we have to just insert into max half, insert in num half. If it, then while max half dot size size greater than the mean half, so just max half dot mean half dot erase, sorry, insert 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 max half begin, and the max half max half max half dot erase max half find max half dot begin, right. This is good. Now else condition mean half dot insert nums. Now while mean half dot size greater than max half dot size plus one plus one plus one plus one, just do same approach. Just take the max half mean half re begin mean half mean half mean half re begin. Compiler error. Okay. It passes. Let's try to do. Yeah, this one is a good question. So this one, let's find how I previously solved this. I solved using the priority key of mean heap and max heap, right? So during addition, I add the mean heap into the max heap. Okay, maintain the mean heap should be greater than the size of mean heap. So yeah, we skip and return. The max heap. So that is for the today. This all for the today's problem, right? Always the lesser max it should else so it's like 2 minus 4 4 and add 4 so it's like 4 it's mean in the mix sizable so it takes the 2 max it dot distributor it's 4 and 4 4 4 now it's come 4 max it 4 now we have to 0 2 max it increasing so it's like more it's like 4 and 5 it's max hip and its main hip right if the max hip is greater then we have to just remove return the max hip dot top so it's wrong let's see how we use the priority queue let me try run it 1 3 max hip max main hip so what max hip 1 is greater than 4 yeah main hip is greater so again 2 now it's 4 it's 4 now main hip so it's like a 4 just this one is good now let's see the today POTT problem like total maximum total subarray value one. You are given the integer of n and k. You need to choose non-competitive array such that the subarray may overlap and the exact subarray can be chosen more than one. The value of zero defined as a and the return possible. So like so I have used all for the cases. approach. Like, can I do like a mini hip? So yeah, you have to do first plus one, right? Like in this question, ready equals constant. That's five, five, that's five, that's over here. That's like what is right over here. Same as like can go at minimum and maximum. Like, it's not allowed. Like a maximum hit should be greater, right? In my approach, maximum hit should be greater size then we have to and maximum size, right? And the five for the five, so it's like a four and five. Now one come, so it's come one, so it's here, so it's equal one and five is equal. Again, come to three, so come to three, so it's come three, so take one here, so it's like given size is increased. So one, three, three, four, five. We have three, so its medium is three. Answer. This is a good question. What I'm trying to do here is like if we use the two set problem, it's 2, 4, 1. Like minimum side, continue. Now it's come 4. Now 4 checking. 4 is checking like you are 2. So it's checking like, yeah, you are greater. So I am going to put in that. Its size is equal. If the maximum size, if the minimum size is greater than, so I am going to put not I am equal. So please put me out that I'm both are equal. So I'm not going to do anything. Now it comes again. So it's I'm going to again put it in that in that way. But the size is greater. So if now we have now again we have we have 1. So I'm little bit nervous, so I'm doing it here. But what I'm saying that size of this is greater than the size plus 1. So the size is increased. One, two, four, five. This would okay. Now let's say today problem POTT. Given totals aware value 1, you are given integer. So maximum sum may be overlap. The total sum of the value of integers aware return the maximum value which you can. What we have to do? You have to find the contribution of each element, right? Like this, how many contribution of each element? Like thing from this 4. So it's like a 4 0 4 4. Not a not a contribution, not a contribution. So it's like a, here it's like a 2 contribution. So it's like a 2 contribution. Uh, okay. So what we have to do? Like 4 2 5 1. Find the next maximum. Find the next maximum. Nothing minus 1. Find the next maximum. Next not maximum. Next maximum. How many contribution this can made? So I have to made. I can made like how many next? How many? I can made like this much. My next maximum should be this. So this much. Like how much contribution I made? 0 1 2. It's 2. Now how much contribution I can make? So it's like 2. How much contribution I can make? So it's like n 1 2 3 4 5 5. How many can do the same? 5. Now for the maximum I can make 2 contribution, and for the minimum can I make the contribution any contribution like 4 3. So it's like 4 plus 4. Okay, so it's like 4 plus 2, and for the minimum, how many contribution I can make? Like minus 1. Anything minimum? Not. So it's a minus 1. Can I make contribution like 2? It's a 1, and there nothing. So first you have to check the contribution wise, right? Like 4 2 5 1. So 4 minus 4 0. 4 minus 2 is equal to 2. 4. Then you can contribute in here. So this much contribution only is provide. Only 2. 8. That means 8 contribution. And how much this contribute to the maximum? It's contribute only 2. How much this contribution provide? They provide, we provide. It's provide like 1, 2, 3, 4, and 5. 5 contribution. Total 5 contribution, right? 5 minus 1. So 5 minus 1 plus 1. 5 contribution. Take like it's like 2. 2 minus 1 plus 1. So it's like only 2 contribution. It's like 2. 2. And there is nothing minus 1. Minus 1 plus 1. It's contribution. Not total contribution. 4251. I think I solved this using the stack. How much contribution this can provide? How much this contribution this can provide? Maximum data. ओके मैक्सिमम का अलग होगा इधर कंट्रीब्यूशन और इधर इसको लेके कितना कंट्रीब्यूशन दे सकता है ये ओके इधर तो -1 और इधर 2 है तो इस मतलब कि ये है 2 कंट्रीब्यूशन दे सकता है 2 into 4 8 ये क्या है ये मैक्सिमम क्या है 0 और इधर मैक्सिमम क्या है इधर से मैक्सिमम क्या है 1 कितना कंट्रीब्यूशन दे सकता है 1 -1 +1 so it's like a 1 contribution दे सकता है राइट या यहाँ है ये कितना कंट्रीब्यूशन दे सकते हैं इधर से मैक्सिमम क्या है कुछ नहीं -1 होगा इधर से मैक्सिमम क्या है ना होगा 5 होगा क्या कंट्रीब्यूशन दे सकते हैं 5 -1 +1 5 कंट्रीब्यूशन 5 कंट्रीब्यूशन देगा एक दो तीन चार so it's like a 4 contribution right yeah 4 contribution 4 contribution now if suppose like contribution तो contribution ही हो जाएगा so that's it for the today guys right let me sorry तो ये क्लिक किए तो मैं okay now I get it yeah element नहीं है ना what should be the answer max 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 mean a written answer this is good uh, why I solved why not showing yeah And this much for